Hey guys, so we are back. We are going to be going over systems of equations and solving them using the substitution method. This is going to be a very quick kind of recap. There's not a whole lot of new information if you know anything about systems of equations. So I'm mostly just going to be going over a couple of examples with you in hopes of better understanding. Usually we learn better in math by doing, so I'm just going to very quickly just jump right into it and go over how to solve a system of equation using the substitution method. So I already printed out a couple of questions that we'll work on. So this is not from any particular textbook or anything like that, so just follow along. I'll try to talk slow, but I do recommend pausing in between questions to give yourself enough time to write down the question, and then that way you can be working it out with me together. So then just make sure that you are kind of pausing this if you are working on this and not just watching me do it, but hopefully you're writing this down and you're going through the steps with me. So I'm going to go ahead and flip the camera. Alright, so as usual, I'm going to go ahead and zoom you guys in as much as I can, and hopefully this will focus. Let's see if it focuses. Alright, so there we go. So it's focused. Okay, so we're going to go ahead and we're going to solve this using the substitution method. So you guys should know now, with the substitution method, what you're going to be doing is exactly what it's saying. You're substituting one expression into the other equation and solving for a variable, because right now we have two variables and we can only solve one variable at a time. So we're going to go ahead, and since that first equation is already solved for y for us, we're going to go ahead and substitute this expression into this y. Okay, so we have 3x plus ry, which is 2x plus 1, equals negative 9. Okay, so again, this is like having an imaginary 1 right in front, and this 1 is not going to change the value of these numbers here. So we have 3x plus 2x plus 1 equals negative 9. Okay, so now our next step is just to get our like terms together. So we want to go ahead and combine these values. So 3x plus 2x gives us 5x. We bring down our 1 and bring down our negative 9. Okay, simple so far. Should be nothing more than just a review of how to solve an equation. Okay, subtract 1 from both sides, and you're left with 5x is equal to negative 10. Okay, to get our x by itself, subtract both sides by 5. Alright, so now we have x is equal to negative 2. Okay, pretty easy, to the point. Okay, to go from this step now to finishing it off, you want to go ahead and substitute your negative 2 into your equation. So we can go ahead and substitute it right back into that original equation. So I have y equals 2x plus 1. Okay, and we know that x is negative 2, so we have y is equal to 2 times negative 2 plus 1. So we have y equals negative 4 plus 1, which gives us a negative 3. So our solution, okay, is, I'm going to go ahead and write it over here. So our solution is an ordered pair, which is negative 2 and negative 3. Okay, now keep in mind that this is a system of equations. What this means is that if I were to graph both of these lines on a graph, that means both of these lines are going to intersect at this point. Okay, now if they're intersecting, okay, that means that the kind of lines you have, like I just said, are intersecting. And now, more importantly, the type of system that we have is a consistent and independent system. Okay, these are independent lines. That means if you do refer to your textbook on page 278, let me see if I can get it on here for you guys. Okay, on page 278, you have this graph. Sorry that it's a little bit, it looks a little bit weird, the angle's off. Okay, but you have this chart here. And now this chart is what's going to basically save your life. because it's really important that you understand the type of solution you have, the type of system you have, which is this top row right here. So consistent, independent, consistent, dependent, or inconsistent. Okay, and what the lines are going to look like. So if you're getting one solution, so you're getting an x value and a y value, that means you're getting one solution only. Okay, if you're getting one solution, that means they're crossing and they are touching at exactly one point. So these are intersecting lines. Okay, and if they're crossing and you have that one point, that means you have a consistent and independent system. Okay, if you have ever a solution that is infinitely many, okay, if you ever get infinitely many solutions, that means that those lines are touching at every single point. So even though this looks like it's just one line, this is really two different lines, but they're overlapping. So the type of line here would be overlapping or coincident lines. Okay, because if they're coincident, that means for me to kind of remember what coincident lines means, I kind of think of collide, because they just kind of look the same, collide and coincide. Okay, so if they're colliding, that means they're one on top of the other like this, and that is a consistent and dependent system. Okay, and for me, the only way that this kind of makes sense to me, and to remember the difference between an independent and a dependent system, for me, I look at independent as separate. Okay, so separate lines, and dependent as the same, or they're one. And so that's how I look at it. And then inconsistent systems, you see that they're not touching. Those are parallel lines, and parallel lines are never going to touch or intersect. And so since they're never intersecting, you never get a solution. So when we're solving a system of equations by either substitution or elimination, when you are left with a no solution, that means that they're parallel lines and it's an inconsistent system. Okay, so going back into our practice problems. Okay, let me move my camera again. All right, so let's go on into this question here. Okay, so we're going to have two more questions on this page. So this one, again, you see that your y is given to you. This one is already solved for y. So we're going to go ahead and substitute this 4x minus 6 into our y. So I have 5x plus 3 times y, which is 4x minus 6, equals negative 1. Okay, so all I did there was simply substitute what I already have for y into this y. But this y is being multiplied by 3, so that's why I'm distributing now to do this. So I have 5x plus 3 times 4x plus 3 times negative 6 equals negative 1. Okay, so go ahead and evaluate that. You have 12x and then minus 18. Combine your like terms. Okay, and now, again, get your x by itself. In this case, now we want to add 18 to both sides. And so we have 17x equals 17. Divide both sides by 17, and you get that your x is equal to 1. Okay, and just like we did before, now you want to go ahead and substitute this number into your equation. So if I know that x is 1, I can now substitute that into my first equation, or even my last equation. It really doesn't matter. I'm going to do it in the first one. So I have 4x minus 6, and I know that x is equal to 1, so I have 4 times 1 minus 6. So 4 minus 6, that gives me negative 2. So I know that y is equal to negative 2, and x is equal to positive 1. So that means that my solution is 1, negative 2. Okay? And those are intersecting lines, just like the last one, and consistent independent. Okay? The only difference is that my solution is going to be a little bit different. So let me kind of zoom out here so you can see, so it doesn't look like I'm giving you the same answer for both. Okay? So this was my solution for this first equation, and now this is my solution for this equation. Okay, now I am going to go ahead and skip this one for now because I want to do some other examples for special occasions or special systems. Okay, now let's go on to this one over here. Now I'm going to zoom you back in. Sorry, the camera's getting a little bit crazy. It's because I'm zooming. There we go. Okay, so let's go ahead, and I think this one was another example that I found. So let's go ahead, and I hope that this is one of those special system one. So again, we're going to be substituting this value. So I have negative 6x plus 3 times 2x minus 4 is equal to negative 12. Again, now you want to go ahead and distribute. So you have negative 6x plus 3 times 2x plus 3 times negative 4 is equal to negative 12. Negative 6x plus 6x minus 12 is equal to negative 12. What do you notice here? Okay, here when I combine my like terms, if I have negative 6 plus 6, that cancels out. It equals to 0. So I'm left with a negative 12 equals a negative 12. Now, what's hugely important is you want to ask yourself, is this a true statement? Does negative 12 equal to negative 12? And it does. This is a true statement. Okay? So when you have a true statement, that means that you're going to have an infinite number of solutions. Okay? Again, this is one of my weird ways of remembering this, and I don't know if it makes sense to anybody else, but in my own head, it does kind of make sense. Okay? If it's an infinite number of solutions, or if it's a true statement, okay, in this case, negative 12 always equals negative 12. Okay, so for me, I look at something like this and I say, okay, well, this always equals that. So if it always equals that, then it's always touching. And what kind of systems are always touching? Okay, so the system would be a consistent and dependent. Okay, and the type of lines are overlapping. Okay, and now again, my solution for, in this case, when it's a true statement, is infinitely many. Infinitely many. Okay? Yeah. Okay, so whenever you have a true statement, that means you have an infinite number of solutions. So that's something that you want to keep in mind. Okay? Now, going the opposite, if you had a false statement, okay, here I said if this number always equals that, then they're always touching. But if that number never equals that, the other number, okay, so if your left side never equals your right side, then that means they're never touching. And what kind of lines are never touching? Parallel lines. And parallel lines have no solution, and they are inconsistent. Okay, so one of the examples that we're going to do here will be that. Okay, so let's see which one it is. Okay, so you'll see in both of these, okay, they look a little different. This one is already solved for you. The bottom one is already y equals, but over here you're going to have to rewrite one of them yourself. Okay, now let's go and do this one first. Okay, so our first one, we have the 2x minus 3. That's the one we want to substitute. So we have 2x minus 2x minus 3 equals 8. So we want to go ahead and multiply or distribute that negative sign. So we have a 2x minus negative 3 equals 8. So this minus negative turns into a plus. Okay, so all I did here was evaluate that minus negative. Okay, and now if I combine my like terms, 2 minus 2, again, that's 0. That cancels. So I'm left with 3 equals 8. And that's not true. 3 does not equal 8. Okay, so because it does not equal 8, the type of lines are parallel lines because they never touch. Okay, the type of solution is no solution because, again, they're never touching. Okay, so if they are never touching, they're never going to give you a solution. There's no intersection. Okay, and the system is going to be inconsistent. Okay, So that's how you know. So if it's a false statement, okay, if it's false, then it's parallel with no solution and an inconsistent system. If it's true, it's going to be overlapping lines that have infinitely many solutions, and it's a consistent and dependent system. Okay, now let's go ahead and let's do this last question here. Okay, now this last question here, we need to solve one of these. Now you can do this a bajillion different ways. You can solve this for x, you can solve this for y, you can solve this one for y, or you can solve this one for x. It really is not going to matter. The only thing I could tell you is sometimes you're going to work with crazy numbers and sometimes you're not going to work with crazy numbers. So I'm going to go ahead and I'm just going to solve this one for y. Okay, so I have 4x minus 3y equals 1. And I want my y by itself. Okay, so I'm going to subtract my 4x from both sides. Subtracting my 4x from both sides is going to give me a negative 4x plus 1 on that side. If I divide everything by negative 3 to get my y by itself, I'm going to be working with fractions for this one. And I know how much we love fractions, but sometimes you got to do what you got to do. Okay? So I'm going to go ahead and that's what I'm going to substitute into my y over here. So I have 6 times 4 over 3x minus 1 over 3 minus 8x equals negative 2. Okay, so all I did was substitute that y value into this y value. Okay, now I'm going to multiply by 6. Okay, so 6 times 4 gives me 24, and 24 divided by 3 gives me 8. So I have 8x. Okay, let's do that with the other one. 6 times 1 is 6, divided by 3 is 2. So I have minus 2. I'm going to bring down this 8 and this 2. I'm going to rewrite these so I have my like terms together. I have an 8x minus an 8x. And then I'm going to move this guy over the other way. So minus 2 equals negative 2. And here we go again. These x's cancel out. So I'm left with negative 2 equals negative 2. Again, this is a true statement. Okay, so I have overlapping lines. Which means I have infinitely many solutions, so infinite solutions. Okay, and these are consistent and dependent. Sorry, you can't see down there. Okay, so overlapping, infinite, and a consistent dependent. So if it's asking you how many solutions, you're going to put infinite. Okay, most of the time when you're solving these kinds of questions, they're asking you for what the solution is. Okay, so your solution in this case is infinite. Your solution when it was false was none, no solution. Okay, so now let's do a quick recap. Okay, you are literally just substituting exactly what it's giving you. Okay, sometimes you're going to have to rewrite an equation. So your step one for all questions is to get one equation and solve for one of the variables. Okay, and then once you've done that and you substitute it in to the second equation, you're going to go ahead and evaluate just like we did. Okay, if it's true, then that means if your variables cancel out, so I'll put here, if variables cancel out, okay, if you're left with a true statement, that means you have infinite solutions. Okay, if it's false, that means you have no solution. Okay? Now, if you happen to be asked what type of system you have, okay, a true solution means that you have a consistent and consistent and dependent system. Okay? But if it's false and you have no solution, that means that you have inconsistent system. Okay? And if they happen to ask you what the lines look like, okay, so if you were to graph them, what are those lines going to look like? These are going to overlap, and these are going to be parallel. Okay, so I really hope that helped you guys. I know that this video is 20-something minutes long. I truly apologize, but I really wanted to make sure that you guys were understanding every single step of the way. So I will go ahead and see you guys for the next one. Have a great one. Bye, guys.